The New York Times publishes hundreds of articles every day, and one challenge they face is how to show all of that journalism to the people who would like to read it. The answer is personalization. In this presentation, Ann Bauer, Director of Data Science at New York Times, will describe how their cross-functional data science teams of analysts and engineers use machine learning to make real-time content recommendation across New York Times website, apps, and emails, increasing engagement with journalism while preserving editorial intent. I hope you enjoy this video.
Hello, I am Ann Bauer. I am a Director of Data Science at the New York Times. I want to tell you about our Algorithmic Recommendations team at the Times and how we are experimenting with content recommendations. I've been working at the Times in the data science group for a bit over 5 years. I came to data science from an astrophysics and cosmology research background via the Insight Data Science program. And for the past year and a half, at the Times, I've been leading the Algorithmic Recommendations team there. So the Algorex team is a cross-functional team of data science, data analytics, and engineering. And our goal is to help create a more personal New York Times by building a machine learning platform for real-time recommendations to deepen user engagement and to amplify the impact of our editorial judgment. So during this talk, I want to give you a good idea of exactly what our team does to meet this goal and how we do it. But first, I think it's worth backing up a bit and asking, why do we want to algorithmically recommend content in the first place? Because the New York Times is known for its editorial judgment, and readers often come to the Times because they want to see the news of the day that's universally important. And this is indeed an essential part of the Times' purpose and mission, and it's not incompatible with also personalizing content. We need to use our space very efficiently and effectively. We publish hundreds of pieces of journalism every day, and there's insufficient space to promote all of this content, especially on mobile. By personalizing part of the experience, we can help articles reach the people who are interested in reading them. Personalizing can also free up editors' resources for the top stories and breaking news parts of the report, which are really very work intensive. Another nice effect of using algorithmic recommendations is that we can increase the lifespan of evergreen articles. Typically, editors will refresh what they're promoting on the site and the apps a few times a day. There are often articles that are relevant on much longer timescales, and we can learn that these continue to be resonant and popular, and we can continue to promote them so that they can get longer exposure. So where do we personalize content at the Times? We personalize a lot of spaces. We work in the apps, on the web, and in email newsletters, and I'll give some examples of each. In the core news apps, our main presence is in the For You tab. The For You tab is the second tab. These are screenshots of the iOS app. And it's a space where we show personalized recommendations based on both active and passive signals. The tab is mainly non-newsy content to be kind of a counterweight to the Today tab, which has the top stories of the day. And we recommend this content based on, for example, of an active signal, an interest that you've told us that you have, or a passive signal might be what articles you've read recently on our site. And you can see here that on the right-hand screenshot, we recommend individual articles. And also in the left-hand screenshot, there are these special collections which are curated by editors that we collaborate with. And then we personalize which one of these and which articles from these you are shown. Another place where we work often is in recirculation models on the article pages. So Here you can see a couple of places that we work in. On the left, you can see the More in US News recirculation block there. This can show up next to or on the bottom of articles in the US News section. The Editor's Picks module shows up really more broadly and has a broader array of content inside it. And we work with the newsroom to define lists of appropriate content for these different types of use cases, from which we personalize which articles are shown to the user. Another collaboration we have is with the cooking team. We do recipe recommendations on the cooking apps and on the cooking website. We work within the recommended for you block, labeled recipes we think that you will love in the top screenshot based on what you've saved in your recipe box. And then also my favorite screenshot with the chocolate chip cookie recipe, we show a ribbon of recipe recommendations based on similarity to the recipe that you're looking at right now. In email newsletters, we have 2 personalized newsletters right now, one weekly and one daily. The weekly one is called Your Weekly Edition, and the daily one is called For You. Here's some examples of those. So now, how do we do all of this? There are a few components to how we make our recommendations. I want to talk a bit about our algorithms, how we work together with the newsroom, our infrastructure, and then also our experimentation. A lot of our algorithms are fairly standard. Some are natural language processing models geared towards content similarity, so recommending articles that are textually similar to those you've read before. For example, we use LDA, we have an NMF and Dr. Beck implementations as well. We also often use collaborative filtering. And this approach recommends to you articles that are read by people with a similar reading history to yours. What is probably our favorite algorithm is our Contextual Abandon. And this is very good at exploring the popularity of new content while exploiting the content that you know is popular. So it's a very efficient way of keeping up with the changing news cycle and making sure that you're really showing content that is optimizing engagement. The context in these bandits can be any number of things. For example, the geography of the user, the reading history of the user, properties of the articles, about what they're about. Examples of using user context could be to show me what's popular for users here in New York, or what's popular for users who, like me, might read lots of science articles. Anna Konen, who is a member of our team, wrote a wonderful blog post about our Contextual Bandit in the Times Open blog, which is a place where you can read a lot of interesting content on what's going on at the New York Times. And so I put a link to the open blog post about the bandits on the bottom of the slide, and you should all go read it. Another aspect of our approach that I alluded to earlier is how we work together with the newsroom to make sure that our personalized results are in line with the newsroom's editorial intent. So how do we incorporate editorial input into these algorithmic recommendations? There are a few different ways that we can approach this. One thing that we found helpful is to try to encapsulate in a score how much the newsroom has promoted an article. For example, if they've put it prominently on the homepage. This gives us a rough way to quantify articles that represent generally important news of the day. And this knowledge can help us differentiate between types of content that are appropriate for different parts of the site and the app. So the quote-unquote algo that we've developed in collaboration with the newsroom is really a rules-based ranker based on the editor's actions in like ranking or promoting content manually. And we use this in combination with a personalized algorithm because, if the space is editorially curated, it's going to be editorially manually curated. but this is a way that we can use editorial curation in some parts of our products to influence how articles show up in personalized areas. Now, another more hands-on way that we can collaborate with editors on our recommendations is by having manual curation of the candidate lists from which we draw the recommendations. So we usually have a different candidate list for each surface that we power. For example, in the article recirculation modules of different types, the recommendations will be drawn from different pools. And so this ensures a variety across the whole experience. This is a way of guarding against things like filter bubbles, where somebody just might come and see the same type of content all the time. And these lists can be manually curated to ensure an appropriate feel for the space. For example, with the editor's picks block, they are actually picked by editors, so that the type of content that appears in that block is appropriate for that space. But which exact instances that you see are personalized to you. Now, a bit about our infrastructure. How do we host all of this? How do we actually make these real-time recommendations? This is a simplified architecture diagram of our system, calling out really that it's divided into two pieces, which are the parts outlined in blue and red. We have a real-time ranking part of our system, which is written in Go, which is built that way because it really needs to be fast. Then, outlined in red, we have where most of the algo training happens. And that algo training service is written in Python. And it's executed in batch, and it's often rapid batch, so maybe every 15 minutes or something like that. But it means that it can be arbitrarily complex, and it doesn't have to meet any kind of latency requirements associated with the serving of the actual recommendations in real time. So just to go into a little more detail about these different parts of our infrastructure, for the batch algo training in Python, the goal of this part of the system is to really just to output metadata per asset. For example, if we're talking about recommending most popular content, the metadata would be just the click-through rate, for example, over the past some number of hours. Or if we want to think about topic similarity, the metadata per article would be the LDA topic vector. It saves this metadata into a key value store, Redis, where it's accessible in real time. And so see, if you go back, you can see that memory store Redis block is really the link between the batch part of the system and the real-time part of the system. The real-time ranking in Go has a few different components. The ranking service fetches asset metadata from Redis, which we just saved in the batch part. It also fetches user behavior from our user history service. So we have, using Bigtable, a cache of user behavior from our site. So what people have been reading recently on site, what newsletters they've signed up for, things like that. And this user behavior can be aggregated into a user vector. For example, if we want to be doing a topic model similarity algo, then we can call our user vector the average of all of the LDA vectors of all of the articles that I've read in the past month or so. So that can describe my interest in one vector. Now, we have to combine this information, the article information and the user information, in order to generate a ranking and really identify which are good personal recommendations. So we have different rankers implemented that know how to understand metadata from the different algos. So for example, if we want to use most popular, we would just simply rank by the click-through rate. You just sort. Whereas with LDA, we would want to compute the cosine similarity between my user vector and the LDA vector of all the candidate articles. And then after computing that cosine similarity, just sort the results. So If you're implementing a new algorithm in our system, there are basically two main components. One of them is to write the Python part where you are interpreting how to convert an article into a numerical piece of metadata, and that can be any number of ways. And then you need to make sure that in Go you have a ranker that can interpret that metadata and turn it into a score. This actually brings up one of the most exciting things, I think, about working in our group is that it's really a cross-functional team, and the production code is written by everybody on the team. And so there's really no sense of data scientists writing prototypes that get thrown over the wall and implemented elsewhere. We all, myself not really included since I lead the team, but write production code. And so we have a good sense of ownership over the results, and it's very satisfying to write code that then actually serves the real-time recommendations on the site. Finally, the last component I wanted to talk about was how we build off of what we've been doing and iterate and improve. So essentially, how do we experiment? Our standard practice is to experiment all the time. Each of our API endpoints in our system corresponds to an experiment config. So for every endpoint, you can break up the audience into as many variants as you want, at whatever allocations you want, and you can test different algorithms, or you can test different candidate pools of articles, or combinations of both. One essential, but I think sometimes overlooked ingredient in allowing for testing is having good tracking across your site. And so this is a body of work that's been done over a long time in collaboration with different parts of the company to really have this all in place. Our API response includes metadata, for example, what algorithm was used in the recommendations. And this metadata is forwarded to our event tracking system upon an article impression or an article click. And so then we can go look it up later and see how many people saw recommendations of any given article and how many of those people clicked on it. And we can use this information both in training our algorithms and in analyzing the performance of our algos in our experiments. So through this process, we've had a lot of success in recommending content throughout our products. I hope I've given you a pretty good overview of all the parts of this process. So please come check it out. Thank you.
Thank you for watching this video by Ann Bauer, Director of Data Science at New York Times. If you like this video and want to watch more technical data science content, go ahead and subscribe to our channel. And we'll see you at the next video.